So, hey everyone, welcome to this session on Create Chaos in Databases. So, this is Saranya, and I, along with Karthik, are going to host the session. And the speaker for this presentation is Vadim Tkachenko, who is the co-founder and CTO of Percona. He leads the Percona labs with focuses on technology research and performance evaluations of Perconas and other third-party products. His expertise lies in LAMP performance and multi-threaded programming, which help in optimizing MySQL and InnoDB internals. So he has also co-authored the third edition of the book, High Performance MySQL, Optimization, Backups, and Replication. So in case you have any questions, please feel free to type in the event section or the Q&A section. And if you wish to interact with our speakers, please do raise your hand so that we can invite you upon the stage. And you can also post your questions in the dedicated Slack channels that I'll be posting the link to the Slack channels I'll be posting in the event chat in a while. So hope you enjoy this session and have a great learning experience. Over to you, Vadim.
Okay, thank you, Saranya. So, do you hear me?
Yes, Vadim, you're.
Okay, great. So let me start sharing my screen, and we will go from here. Do you see my screen? Yeah, I guess that's yes. So
Yes,
let's
yes.
go. So thank you everybody for joining. I'm Vadim Tkachenko, CTO and the co-founder of Percona, and today I would like to share our experience with databases in Kubernetes and why we're looking to create chaos in there. And I am not sure if you're familiar with Percona. That's why I will spend a few minutes to describe what Percona is, and I promise it's relevant to this session. This session. So Percona is open source database provider. We provide services and software, and our focus is open source solutions. We trying to provide the solutions that avoid vendor lock-in, and we're looking to help you to eliminate slow application and reduce your database cost. And Percona, that's we make sense of databases, and currently databases infrastructure are more complex than ever. So we will help you to manage, deploy, and optimize databases to meet your needs. And we support a variety of databases and the platform, MySQL, PostgreSQL, MariaDB. We run on Kubernetes, we run on clouds. We can help you with any databases and with any open source database on any platform. So let's talk about Kubernetes and databases. And for Kubernetes, we currently have two offerings: the Percona XtraDB Cluster and Percona XtraDB Cluster Operator, and the Percona Server for MongoDB Operator. And in this talk, I will talk mostly about Percona XtraDB Cluster, but many ideas will apply for Percona Server for MongoDB too. So let's go a little bit what Percona XtraDB Cluster is, because I imagine many attendees might not be familiar with this product. And again, this is open source product, but what we do, we take regular MySQL servers and connect them in multiple nodes, which communicate between them through group communication. And with this setup, we trying to achieve several goals. We trying to achieve to provide you a high available solution. We run on multiple nodes, and when one node goes down, other nodes will continue to serve application. But a bigger goal is to guarantee data consistency. Basically, at any point of time, whatever node you will take, that will guarantee your consistent data. And consistent data, I mean in context of fully transactional SQL workload. Whatever complex transaction you run, whatever concurrent transaction you run, we guarantee that data will be consistent. And if you work with one node and then you switch to another node, we still guarantee you a consistent data view. And this achieved by synchronous communication between multiple nodes. And you can imagine it applies, it requires a few critical components for Percona XtraDB cluster to work properly. And one component is storage, which obviously storage performance is critical for whole database performance. And obviously storage is critical component, obviously network. That's also network performance and network stability is critical to achieve connectivity between nodes, to provide communication and message delivery. And you may know that two components are very fun to work in Kubernetes, and we are trying to solve challenges which comes with that. So why do we focus on Kubernetes? You may know databases in Kubernetes may not be always that friends, but in Percona we decided to focus on Kubernetes as by several reasons. One of them, we know many companies using thousands of databases, and we're looking to simplify database management. Currently, very popular way to define infrastructure is as code. So we would like to apply the same principles to databases. You can define your databases and the unit infrastructure as code. And Kubernetes, with its multiple distributions and the flavors, I believe already became industry standard to manage such environments. And we believe that Kubernetes, being open source project and backed up by many companies, allows you to avoid locked-in lock-in solution, which again what Percona is focusing on, to provide open source, avoiding vendor lock-in solutions, and that you still will be able to get database databases running as a cloud database. And with Percona Operator, with this we decided to develop our Percona Operators for critical databases like XtraDB Cluster, which is based on MySQL and MongoDB. And our operators, they provide multiple benefits, such as automatic provisioning and configuration management, upgrades to minor and major versions. We provide fully automated backup and recovery capabilities. We include our monitoring, which allow you to look what's going on inside of databases. And we develop our operators to utilize only Kubernetes API and nothing else. So we see great benefit of using operator primitives. And with Percona XtraDB, with this Percona XtraDB cluster, will provide again you fully automated deployments, high availability solution for your database with no single point of failure. We're also trying to achieve fully automated self-healing logic by automatically recovering from failure of here I say single database member, but really it depends of how many database nodes you're running, and we require all the numbers of database nodes, where odd being 3 or more, so we can predict how we can recover from failures. For example, in case of 3-node cluster, we can survive 1 pod failure. In case of 5 cluster, we can survive 2 pods failure, and in case of 7-node cluster, we can survive 3 pods failure. And also, we are looking to achieve recovery from total network outages. So with this frequent question we've been asked in Percona, so is Kubernetes really ready for databases? And as we decided to make this Kubernetes efforts already a couple of years ago, my answer is probably yes. And even during this year, I believe network plugins for Kubernetes improved significantly. There are great progress in the storage and snapshot capabilities. There is a progress in the operators API. So my belief that Kubernetes is ready for databases. However, next question is, should I use Kubernetes for databases? And here is the answer depends really on your environment. With this mentality, we still see a lot of database usage as, let's say, pet servers. I believe you should be familiar with this pet versus cattle concept. And while Kubernetes encourages cattle mentality, still a lot of environment depends on a very single or very small amount of dedicated high-end database servers. It's a very expensive, very high-end performance-oriented hardware capable database servers. They have a dedicated DBA team for the database server, and one database can handle multiple application and workloads. So in this case, I see it would be very hard still to recommend Kubernetes for this kind of environment. And where we could see a very good fit for Kubernetes with our operators is where you have multiple teams, and multiple teams, they have multiple database servers. I probably would start looking into Kubernetes environment when you have over 30 database instances, where you're looking to create database instances on demand, where you can have disposable databases for testing and dev usage. Maybe you even don't have a dedicated DBA team, and this is where our operators will try to take over a lot of automation and a lot of DBA work. And we rely a lot on automation with our operators. So, and we believe our operators in this kind of environment should be ready to serve your database traffic. In this, let me then switch what we're looking for from Chaos testing. And while I say that Kubernetes is ready to serve databases, my opinion that Kubernetes kind of multiplies multiple problems, because we're speaking about massive scale deployments, very automated. There is unpredictable application workloads on database instances, where unexpected queries, unexpected bugs might come to surface. And there is still Kubernetes rely on network plugin software, on storage plugin software, and we know it comes with bugs. So with this limitation and our goals to achieve fully automated self-recovery, recovery from full network outages, we need a way to be able to test and emulate outages. And I think this is where Kubernetes, when it multiplies a lot of problems, it also makes this testing kind of easier. So the idea is, if we can automate a database deployment, why cannot we automate failures? And this is where I started to look into automating failure scenarios. And fortunately, I could not find it initially, but then I found, I think, two interesting products which are available right now. Chaos Mesh, which I found it first basically, and I'm more familiar with this. So all the following examples I will provide using Chaos Mesh product and the Chaos Mesh YAML file definitions. But there is also interesting project Litmus from Maya Data, who is hosting this conference. And actually tomorrow there is Maya Data will provide a demo for chaos testing with Percona XtraDB Cluster and Litmus during Percona Bootcamp. And I will be available during this demo, and we may be able to talk and discuss what's going on here. So with this, right now, I will describe a little bit what the kind of scenarios with Chaos Mesh we are looking for in our testing setup. So what we're looking for chaos testing. Initially, I took very simple setup. In this case, this is what you will see when you deploy Percona XtraDB operator by default. You will get 3 pods running Percona XtraDB cluster instances, and the 3 pods running HA proxy. And we use HA proxy to kind of first load balancing, and then maybe for a failover mechanism where HA proxy will direct application traffic to available database pods. By default, for example, we can route traffic to pod 0, but if pod 0 becomes unavailable, HA proxy will be able to reconfigure traffic to available pods. And in following examples, I will use sysbench TPCC. This is benchmark program, and I will emulate some benchmarked workload on database while applying some chaos disruptions. And what we want to test with our focus on high availability and automatic recovery. I primarily looking for 2 kinds of disruption. First one is a pod disruption, where we can emulate node crash or it's getting lost. And I'm looking to emulate all kinds of network disruption where partial link between two nodes lost, where when all node loses all its links. And there are even more network disruption available, like network corruption, network errors, but that's more advanced. And now for pod disruption, we can run a very simple case, just basically kill one of available pods. Again, our setup is 3 pods, so our cluster should survive one pod being unavailable, and then when pod becomes available, because Kubernetes will reschedule and respawn pod later, that cluster should perform self-healing and return back to 3 nodes setup. And we can perform this operation, and really when we observe sysbench traffic with 1 second resolution, here I highlight how you can see this behavior in a sysbench. You will see every second it performs over 500 queries per second, but when disruption happens, it actually stops serving traffic for about 5 seconds, and the 5 seconds is a configurable variable in Percona XtraDB cluster, and this based on the timeouts. So we lost one pod, and the Percona XtraDB cluster is trying to connect to that pod for 5 seconds, but then when 5 seconds expires, Percona XtraDB cluster will be able to continue operation now with only pods available. And you can see after 5 second interruption, it will continue to serve your traffic. Second scenario which I would like to show is network failure. In this case, we just will cut a network link from pod 1 to pod 0, and the trick part is that in direction from pod 1 to pod 0, and let's see what's happening in this case. And you can see in the definition we are looking to disrupt this network for 25 seconds. But actually, what's interesting happening when we deploy this network disruption, we can see that our traffic was affected only for about 3 seconds, and this is where one interesting part of Percona XtraDB cluster comes into play. As you know, we have 3 nodes, and all 3 nodes communicate with other. And if we only cut one link, there is still another route available. So this is what happens. Percona XtraDB cluster link is down, but the node still will be able to communicate through relaying messaging through another node. So, and it takes only 3 seconds for it to figure out and then restore communication. So, to be able to properly test network failure, we need to cut all connection to this node. And in this case, again, we're looking to cut out all network communication with pod 1. So we cut network to pod 0 and cut network to pod 2. In this case, we will guarantee that pod becomes totally unavailable for network communication. And what happens in this case? In this case, basically, it's kind of for whole Percona XtraDB cluster, it will be the same as pod failure. Percona XtraDB cluster will will try to communicate with pod 1 for 5 seconds, and then when no communication, no response available, it will continue as a two-node cluster for time being. And we can see if even network was disrupted for 20 seconds, application is stalled only for 5 seconds, and then is able to continue to communicate with database. Now, what happens if two pods lost connectivity? And remember, you said when we have 3 pods set up, and this is what we have in this case. We guarantee that we can guarantee only 1 pod failed. But really interesting to see what happens if 2 pods failed. And we can deploy this scenario, and we can see this bench will throw some kind of errors, and this is expected that cluster will not survive, but we see that application actually not able to handle this error properly. And I would like to show this point, that the importance of this testing from application standpoint, that application can expect all different kind of errors from database, and the application, you should test your application, and you should make sure that application is able to handle errors which comes with different kind of failures properly. Of course, you don't want your application just fail in case of unexpected error. So in this case, I kind of showed you happy scenarios when database was able to survive network disruption. But actually, during my preparations for this presentation, I tested the multiple scenarios. And actually, I would like to show 2 scenarios where Percona XtraDB cluster failed to recovery, and that was a benefit for me for working for this presentation. And this is not a happy scenario. And actually, I tested very simple. In previous case, I disrupted network to 1 pod for 20 seconds, but then I tried to disrupt it for 60 seconds, and I found out that actually Percona XtraDB cluster is not able fully recover in this case. In this case, isolated node, when trying to join after being disconnected for 60 seconds, it crashes again. And I filed this bug, and now it's being worked on, and we should resolve it and fix this problem. And another problem which I found out during this testing, for example, if we take more aggressive network outages, for example, we looking to disconnect a pod for 20 seconds, and we do it every 30 seconds. Well, again, I expect a cluster to be able to continue. There's only pod 1 should be affected, but the whole cluster should be able to operate properly. Unfortunately, this is not what happens, and I filed another bug. And after several of such network frequent disruption, my application actually got stuck, and some queries got stuck in some interesting state, and the application is not able to proceed. So another benefit from this chaos testing that I already found 2 very interesting bugs in our Percona XtraDB cluster software. So with this, I'm very enthusiastic about chaos testing capabilities, and the benefits I see from chaos testing. It's very easy to define failure scenarios. It's very easy to automate failure testing, and we can coverage multiple failures scenarios and even chain. So what example if a network goes down, then pods get killed, or network bandwidth becomes unavailable, or we can apply some stress workload on one another pod. So that, in my opinion, will provide a variety of different failure scenarios, which for us, for database developers, are very valuable to be able to run and to find any bugs before users should find them. And for this, I think very important to think not only Chaos as a testing tool, not only for operators, developers like Percona, so not only database software company should look into Chaos testing, but I see benefits if you deploy your application with a database. You should apply Chaos technique to whole setup. You should be able to see how your application reacts to database failures, and if your application is able to recovery from network or node disruptions, which database software will be subject to. And I think that's end of my presentation. If there are any questions, I will be happy to answer.
Hi, Vadim. I think
Yes.
that's a wonderful session. Thanks for sharing us the knowledge around running databases on Kubernetes and what kind of chaos tests you can execute on them. Just had a couple of questions around this. So, considering we are dealing with data here, when we are doing these chaos experiments on large systems, let's say they are staging clusters where you have a lot of data, or sometimes even in production if people feel their environment is quite mature. What are the considerations or precautions you might take before you could go ahead and run these experiments? Do you see any such activities that you need to be doing before doing these chaos experiments?
Interesting question. Actually, did not think about that, and I would not think maybe to run it in production. But as you ask, I think it might be good idea to run it in production. But of course, you have to be very cautious, because who knows? Maybe you will uncover something what you don't expect, and your application will not react properly on this disruption. So at very least you should have a rollback plan, where if something unexpected happens, how you recovery from failure, how you roll down a chaos experiment, and if database or your environment is still on a recoverable state, how you would get back to normal state. So of course there has to be let's say rollback plan, how you will get to a normal state from in case if you experience an catastrophic failure, and very least how you would recover, for example, from backup if a database does not come to life by itself.
Cool. Yeah, I think that was helpful. Another question, since you mentioned in one of the chaos tests, you were injecting some network latency after every few seconds interval. When you're running chaos experiments like this in an automated manner, or let's say it's being run as part of some kind of a pipeline, let's say as part of the CD pipeline, are there some checks that you might want to add, automated checks you might want to add inside of the chaos experiment itself as part of the hypothesis that you might have had for that use case? Like you are looking for some downstream applications availability, or you're checking for some status on the Percona CR, for example. This might be more relevant in case of databases being managed by operators, looking for some state of these Kubernetes resources or some end application availability or running data integrity checks, for example. Do you think these kind of checks find a place within the experiment itself, or do you think that's something that should be users?
No, I think that would be very valuable, and you need to see how many checks you should have. But for us, actually, what is more important for database providers, even we are database providers, for us, application availability is still more important. So I would envision checks that your application is still working, your application is still able to connect to database, your application is still able to extract data or update the data in the database. And also, is Percona one of focus of Percona is performance. That also I would add the performance metrics. It's not only that application is able to extract data, but it's able to extract in a defined manner. So, for example, if under regular workload application, it takes 1 second for database to execute query. If under stress, it becomes like 10 seconds or 100 seconds. That also I would consider as a failure scenario and as an unacceptable outcome. So that's I would add it to monitoring metrics also.
Awesome. I think that was indeed helpful. I think that's the only set of questions I had. Does anyone in the audience have any questions for Vadim? You can feel free to raise your hand and we can bring you on stage, or you can post the questions on the session chat as well.
So, Karthik, we have one more question. You can check the Q&A. So, let me read them out. What are advanced monitoring for database from Percona monitoring?
For Percona monitoring, Percona also shapes this product, Percona monitoring and management, which is oriented for very detailed database management. And we support MySQL, MongoDB, Postgres, and the Percona XtraDB cluster. And now we integrate our monitoring of our operators into Percona monitoring and management. So when you deploy our operator, you also automatically will deploy a monitoring agent, and if you have your Percona monitoring and management running, you will be able all kind of metrics. I believe there is over 1,000 of different metrics available how you monitor your database. But metrics is not only story. We in Percona monitoring management, we also provide query analytics, because we believe that query is what more often than not causes problem for database performance. So you also should be able to monitor and diagnose your queries you're running in your database.
Okay, thank you, Vadim. So we have one more question. What are the supported database cluster nodes? primary, secondary, multi-primary. Is even sharding possible with Percona?
All right, yeah. So maybe I should focus more on Percona XtraDB cluster. And so with Percona XtraDB cluster, because it's a synchronous solution, really you can work with any node as you want. So you can say this is multi-primary solution, but really we don't see much benefits to use it as multi-primary. That multi-primary capabilities comes into place when you're looking to achieve high availability state. And for high availability, when one of primary goes down, you can easily switch to another primary. So Percona XtraDB cluster is multi-primary deployment, but we recommend to use only one primary at any given point of time. As for sharding by itself not available in Percona XtraDB cluster, but there are other products like VTES for MySQL that can help you to solve a sharding problem for database in Kubernetes.
Okay, thank you. I hope, Frank, your question has been answered. So we have one more question. What are major issue with databases happens, and did you overcome it using Chaos?
So major issue, of course, for many users, they are afraid when database becomes unavailable. It's when it becomes outage, and of course, when your database connected to your website, that means website outage, and we really strive to provide the database available at most time of when possible. And from my experiments, I showed in some cases database is able to survive some chaos disruption, but I also showed that I found two bugs which we still suffering from, and I hope we will solve them soon, and the Percona XtraDB cluster will be even more solid than before.
Okay, so I hope your question has been answered. Yeah, so we have around 3 minutes left. So we can take the questions to the channel, or you can just send it here. We'll wait for a few minutes.
Yeah, I probably also make the announcement that we do have a bootcamp session tomorrow on day 2, where we will be executing some chaos on Percona XtraDB cluster with monitoring setup, the PMM monitoring that Vadim talked about. Percona monitoring management agents server will be set up. So some of the issues that were covered today, you could probably take a look at that during the bootcamp tomorrow. So do join us for that session. And yeah, I think that's the announcement we had. If there are no more questions, we can go ahead and end the session. Thank you, Vadim.
All right. Okay. Thank you. Thank you, everybody. Thank you.
Yeah. So thank you. And there's a. Okay. So shall we end the session?